Okay, so now we will move on to the Claisen condensation and other Claisen type examples. And the Claisen is similar in some regards, but at the same time, fundamentally different from the mechanism of the aldol reaction. The Claisen is when the leaving group or the electrophile contains a leaving group, and it could have more than one, but the aldol was a carbonyl electrophile like an aldehyde that had no leaving group. Now the Claisen is going to involve a carboxylic acid derivative electrophile. Generally, when this leaving group is an alkoxide, like an ester. So we'll do a couple examples, starting with ester electrophiles. Like the aldol, there's a self Claisen. And the self Claisen is going to involve the reaction between two identical esters in solution. Unlike the aldol, we now have to add a specific base dependent upon what the ester starting material is. If the leaving group of the ester is an ethoxide, you must use sodium ethoxide base. If it were a methyl ester, you would use sodium methoxide. Because esters are fundamentally different in that they have leaving groups. Aldehydes do not. And so you have to make sure that if this leaving group were to be displaced in solution, if that base were to attack as a nucleophile, you want to make sure it doesn't change the ester or transesterify to a different ester. That would give you a mixture of different products. We don't want that. So when you see that the leaving group matches the reagent, that means don't attack the carbonyl. That will be pointless. Instead, deprotonate the alpha proton.